right, hello everybody. So I put a pretty nasty induction proof onto the test about differentiation just to see if you could put those ideas together. I'll show an example that's similar here. So let's say that we have a function like 1 over x plus 1, or 1 plus x, doesn't matter. And I want to come up with a formula for the nth derivative and then also prove that the formula holds. So first let's try to find a pattern. And I made it a little bit easier on you. Easier is maybe subjective, because I told you what the pattern would be. In this video, I'm just going to figure it out. I actually don't know what the pattern is at this moment, but I bet we can find it. So if we do negative 1, 1 plus x to the negative 2, that's going to be the first derivative. The second derivative is going to be positive 2 times 1 plus x to the negative 3. The third derivative is going to be negative 6 times 1 plus x to the negative 4. I hope we can kind of see what's happening here. So we multiply and then bring the power down by 1. So here then is my conjecture that the nth derivative is going to be n factorial times 1 plus x to the negative n plus 1. But that's not quite right, because it is flip-flopping from positive to negative. So I'm going to have a negative 1 to the n. I'm going to double check that that's right. Yeah, because when I have odd powers, those are negative values right there. So that's my conjecture. So then what I'm going to show you is that this conjecture is true. I could actually start when n is equal to 0. And if I start with n is equal to 0, I already have the function here. I could have also started with n equals 1 and then moved on from there, but that is also correct. When n equals 1, we get exactly the statement as shown. So now the part that is more interesting is assuming that the nth derivative is as conjectured below, and then trying to prove what the next derivative is, and showing that when I go to the next derivative, that it's going to look just like that with all of my n's iterated by 1. Okay. So let's just clear out just a little bit more of the junk there. All right, so we're going to assume that the nth derivative is our conjecture. And then we are going to look at the n plus 1th derivative. And so with the n plus 1th derivative, we're just going to multiply the power in front. So I'm multiplying by negative n plus 1. I'm writing 1 plus x. I'm subtracting 1 from the power. And then I'm going to apply the chain rule, even though the derivative is just 1, just to be really explicit about each of the differentiation rules there. Then I'm noticing that n factorial times n plus 1 is n plus 1 factorial. I'm noticing that this negative right here is really another negative 1. And so that makes this. Those link up to make negative 1 to the n plus 1. And I'm noticing that here we have 1 plus x to the negative n minus 1 minus 1. And so altogether then, we have that the n plus 1 derivative is what we wanted. -1 to the n plus 1, n plus 1 factorial, 1 plus x to the negative n plus 2. So we're done. So I'll show you another one in a separate video where we are using induction to prove a general formula for the derivative. So please comment if there's anything that was confusing. Happy to help.